Hello, Assalamualaikum. We are from Faculty Mechanical Engineering. My name is Muhammad Nasruddin bin Ridwan.
Hi guys, my name is Mariam binti Rosdi.
Hi guys, my name is Muhammad Aidin Aishamdi bin Azwan.
And I'm Johnson Mefredan. Today, our case study will be focusing on the metal casting workshop. And the objectives of our case study today is to analyze the safety and sustainability practices used in metal casting workshops.
Next is to identify existing technical, safety and sustainability issues.
The third one, to propose the actionable solution that require to relevant code and respond.
And the last one, to evaluate the balance between cost, safety and environmental impact.
And now we will look at our proposal of solutions and applications of codes and standards in the metal casting workshops. We would like to propose 4 solutions, which is enhanced engineering controls and training, implementation of a foundry sand reclamation system, structured preventive maintenance and calibration schedule, and ergonomic and process improvements. For our first solution, we should install local exhaust ventilation systems at melting and pouring stations. This directly addresses fume inhalation and aligns with the Occupational Safety and Health Act 1994, which mandates control of hazardous substances. This improves air quality, reducing the environmental release of particulates and fumes. And for our second solution, we should invest in a mechanical sand reclamation unit to process used sand for reuse. This aligns with the ISO 14001 Environmental Management System principle of resource efficiency and waste minimization. This reduces the volume of waste sand, minimizing manual handling and storage hazards. It is a core sustainable practice that closes the material loop. For our third solution, we should implement a strict documented schedule for inspecting crucibles, furnaces, and calibrating parameters. This is mandated by the Factories and Machinery Act 1967, which requires safe operation of machinery. This improves energy efficiency by ensuring furnaces operate at peak performance while reducing energy waste and associated emissions. And for our last solution, we should introduce roller conveyors for moving molds and castings. We should also develop and enforce standard operating procedures for all casting stages. This supports the MEM160 Occupational Safety and Health Management System requirement for hazard identification and risk control. This reduces physical strain, promotes a culture of orderliness, and minimizes errors that lead to material wastage.
Okay, now I will tell you guys about conflict required in workshop industry in metal casting. I have a 3 conflict that can be happen in workshop environment for metal casting, which is a cost versus quality. Second is production speed versus dimension accuracy. The third one is cooling speed versus a product strength. That I will tell you a justification and for the solution that can be used in industry. Okay, firstly, I will tell you guys about cost versus quality. In this part, it focusing on material selection for making a mold and to finalize the product. Okay, the justification is if we use a cheaper sand for making a mold, the advantage is on the price of the sand, but the quality will be bad. Using the river sand, for example, we are using a river sand. Okay, the river sand is a cheaper sand that can make a mold, but the river sand cannot be added with the high temperature. For example, for making a casting, this metal casting that use 800 Celsius aluminium. So we cannot use a cheaper sand for metal casting. So I have one solution for this justification, which is buy a mid-range price of the sand. Okay, why a mid-range? Mid-range, so it be a middle of the price, of course, and also it will have a quality of the sand. For example, red sand. Red sand can be added a temperature like 800 to 1000 Celsius. Okay. Next, I will go on for next. Okay, for the second one is production speed versus dimensional accuracy. On this part is focusing on effected on product. If worker in industry want to finish their casting quickly, so they can produce more than standard time for casting, but the dimension will be not constant or specific. In this statement is mean some worker or some people want to finish their work or making their product making many of product, so they want to finish their work at that time quickly. So there will be not the dimension will be not same as first thing that we are planning. Okay, so for this solution of the statement is worker need to make a item properly and make a step by step. In this statement is mean worker need to make a procedure carefully. That mean for making a mold, they need to making a properly and their safety. So the finalize of the product will be a perfect product. Okay, so we continue for the final conflict. Okay, the third one or the last one of the conflict is cooling speed versus a product strength, which is focusing on finalized product after pouring the metal in the mold. Okay, the justification is if we cool the metal too fast, okay, it have saved the time and increase the productivity. Okay, in this part it means we want to rushing to make the product, but we not taking a time to make it hard, so it be affected because affected to the product is it can be cracked or and internal stress in the casting. So in this statement we have a solution, which is let the product cooling in the air to make sure its hardness is perfectly, and after the product is perfectly hard, and we can take the product and put it in the water, and we can see the difference of the we making it fast cooling, and we taking a time to take its hardness of the product is perfectly. Okay, that's all.
In conclusion, our analysis has met its objective, revealing critical gaps in the metal casting workshop, safety and sustainability. While foundational practice at risk, significant risk from fumes, ergonomic hazards, and the unsustainable linear disposal of foundry sand were identified.
Based on our evidence, we would like to propose a green sand initiative to transition to a more reclaimable sand system for practical training. Secondly, we would also like to introduce safety stand-down sessions where students and staff work together to identify potential safety hazards in metal casting workshops.